Good morning and welcome back. I hope you all had a great holiday. This semester we're going to be jumping into exponential equations. But our first lesson we want to review and expand on some transformations. So we did transformations last semester. And we do them off of our parent functions. The parent functions are the original equations for different graphs like a line, a parabola, all of that. But it's without them being shifted or stretched or steeper or flatter or any of that. So our first parent function, y equals x, that's just your basic linear function. And the shape of that graph is just going to be a line. It's just going to go straight up in a line. Our second parent function, x squared, that is quadratic. That squared creates a parabola, which is a U shape. So it's going to look like a U. Our third one, what are these bars around x called? Those are absolute value bars. So this is called absolute value. And that graph looks like a V. So it's just going to be straight V. And the last one, what symbol is this? This one's a square root symbol. So it's called a square root function. And that one sort of looks like a half parabola. It's sideways. It just kind of shoots off to the side. So it's a half parabola. So these are the functions that we're going to use to do all of our transformations with. So a little recall on transformations that we've done in the past. What is our transformation on this first equation? We have x minus 3. So what is minus 3? Well, that is just going to be a vertical shift, and it's minus, so it's going to be a vertical shift down 3. Okay, then what about 2? We have a 1/3. What does a 1/3 tell us? That's going to be, it's between 0 and 1. Your slope is between 0 and 1. So that's going to be 1/3 times flatter. If it was greater than 1, it would be steeper, but because it's between 0 and 1, it's flatter. And then what about 3? For 3, we have that negative out front. Do you remember what that negative meant? That's a reflection. It's just going to turn your graph over. Instead of your line going up, your line's not going to go down. It just turns it over. What about the 2? Well, that's going to be 2 times steeper because it's greater than 1. The negative is separate. The 2 is greater than 1, so it's steeper. And then what about the plus 5 at the end? That's a vertical shift. It's plus, so it's going to be up 5. That's your y-intercept. It's going to move it up 5. Okay, so we have the basics. We learned all those last semester. We're just going to add a couple more things. So we know our normal y-intercept. If there's a plus or minus at the end, you're going to vertical shift up or down. It can also be called translation. We're going to stick with shift, but if you see translation, that just means the same thing. It's moving up or down. If it's positive, it's going to go up. If it's negative, it's going to go down. Now, we haven't looked at them with quadratics or absolute value or square root, but if we have it on a linear, we're just going to have that plus 2 at the end. If we have anything else, quadratic, square root, or absolute value, There, plus 2 is going to be at the end, just like linear, but it's going to be outside the symbol. So outside the absolute value, or outside the squared, or outside the square root. It's not going to be included in your group. So that's a vertical shift. It's just going to be at the end of your equation, and it's going to say plus or minus a number. This semester, we're going to show you horizontal shifts. They can also be called translations as well. Like I said, we're going to stick with shift, but if you see translation, it means the same thing. When you see a horizontal shift, those are going to be inside the grouping symbol. The grouping symbol can be a parenthesis, it can be an absolute value, or it can be a square root. Whatever it is, it's going to be inside the symbol. Horizontal shifts are going to tell us if we're going left or right. And it's going to be the opposite of what you see. So if you see a positive 2 on a number line would be over to the right 2, but we're actually going to go to the left 2. We do the opposite. So these are going to be grouped. They're going to be inside your parenthesis, inside your square root, or inside your absolute value. And you're going to do the opposite. Not this big. So this was a negative 2. On a number line, negative 2 is on the left, but horizontal shifts do the opposite. So they're going to go to the right 2. They're actually going to come over to positive 2. Okay, and then when our slope, this is just slope, if your slope is greater than 1, we call that steeper. We have a new word we're going to look at, and it's called stretched. Stretched by a factor of whatever the number is. It's the same thing as steeper, but normally they're going to use the word stretched. So whatever your number is out front in the slope spot, if it's greater than 1, it's going to be stretched by a factor of 3 in this case. Last semester, we also looked at slope that was between 0 and 1, and that we said was flatter. This semester, we're going to call it compressed. That's another word they could use to describe the slope when it's between 0 and 1. So instead of using the word flatter, when your number is less than 1, we're going to compress it by a factor of whatever the number is. In this case, 1/2. So whatever your number is in front, if it's between 0 and 1, it's going to compress. And then, just like before, if we have that negative on our slope, that's a reflection. It's technically called a vertical reflection. There is a horizontal reflection, so we want y'all to be very specific with, we're not going to talk about horizontal yet, but we want y'all to be very specific with vertical reflection. That just means, just like last semester, it's just going to flip. So if we had a line that was going up, if there's a negative on front, it's going to go down. If you have a parabola that's going up, if there's a negative on the front of it, it's going to flip and go down. That's all that negative means. The negative has to be in front of anything. In front of a parenthesis, a square root, an absolute value, anything. So it's called a vertical reflection. Okay, so let's see if we can label these. So we're going to describe each transformation of the parent function, and then we can check it in the calculator to see how it was really transformed, to see if we're correct. So for this one, we have a -5, and it's inside the square root. Which one up here was inside a grouping symbol? That's right, our horizontal shift. Those are going to be inside the groups. So this is going to be a horizontal shift. And remember, horizontal are going to do the opposite. So -5 is usually to the left, but because it's inside, we're going to do the opposite. And we're going to go to the right 5. And we can check it. So we can go to y equals. We're looking at a square root function. So I'm going to put our parent function in first. You can go back to the top of the page. The parent function for square root is square root of x. Not squared. Square root. Why is this not square rooting? There we go. Square root of x. And then I'm going to plug in this equation. Square root of x minus 5. And then we can check it out. So graph it. This is our original. It's just going to shoot off from the middle. And our new equation moved over 1, 2, 3, 4, 5 spots to the right. So it was a horizontal shift right 5. So we know our transformation is correct. Okay, let's try B. So we got absolute value of x plus 2. Plus 2 is on the outside. So which transformation was on the outside? Outside at the end is going to be your vertical shift. Those are just going to be tacked on to the end. So this is going to be a vertical shift. And we don't have to do anything special. It's positive, so it's going to go up 2. And again, we can check this out. So we got an absolute value. So that's going to be our parent function. Make this a little smaller. There we go. So absolute value of x is our parent. And our new one is absolute value of x. And then outside, so hit the right button, we're going to add 2.
Second, grab and go, blue day, head to the cafeteria.
Okay, then we graph it. Our original is always going to go through 0, so that's our original. And our new function, it shifted up 1, 2 spots. So it would just vertical shift up 2. So you can see exactly how it changes. Second, I'm trying to figure out if I can change the color. Okay, this will be better because we'll have a color. Okay. So the third one, we have this 1/2 out front. What were the numbers out front? The numbers out front are either going to be stretched or compressed, which we used to say steeper or flatter. It's 1/2, so it's between 0 and 1. So is that stretch or compress? That one's going to be compress. What we used to say is flatter. So this is going to compress by 1/2. Okay, then we have this -3, and it's inside the parenthesis. Which transformation was inside a group? Right, your horizontal shift. And what's special about horizontal? They're going to do the opposite. So this is -3. On a number line, technically -3 goes over to the left of 0. But because it's in a group, we're going to do the opposite. So we're going to go to the right. That 3. And let's check it. It's old stuff. So what do we have here? Our parent function is x squared. So you can go up to the top and get that parent function. So we're going to x squared. Our new function is 1/2 parentheses x minus 3 squared. Then we can graph it. So our parent function is in blue. That one's going to go through 0, 0. On this one, they both went through 0, 0. Oh, nope. Okay. Now that I've zoomed in correctly, we can see that it didn't go through 0, 0. It shifted. So it's hard to tell the compress on a graph. You can see that this red one is a little bit more open, so it's kind of pushing it down and widening the parabola. That's a little bit harder to tell on these graphs, but you can definitely see your shift. It moved over 1, 2, 3 spots to the right. So we know we're right. It compressed, it got smaller by 1/2, and it was a horizontal shift right 3. Okay, let's look at the last one. On D, we have a negative out front. What is a negative out front? That's always what it's always been. That's a reflection. This semester we want you to focus on vertical reflection because there is such a thing as horizontal. So this is a vertical reflection. Then what? Well, we have this -1 outside. What transformations are outside? At the end. That's going to be your vertical shift. If it's at the end, outside, it's a vertical shift. And it's negative, so it's going to go down 1. We can graph it to double check. So our parent function, what symbol do we have here? We have a square root, so that's going to be our parent function, square root of x. And then we plug in our new one, negative square root of x, go outside the square root, -1. So our parent function's in blue, our new one's in red. So our parent function's this blue one, started at the origin, goes off like it's supposed to, just shoots off to the right. Our new one is upside down. That's where your vertical reflection comes in. It moves it and it makes it upside down. Then it moved down 1 spot. That's your vertical shift down. So it flipped it upside down, vertical reflection, and it moved down 1, which is your vertical shift down. Okay, next page. So, what you want to watch for when you're looking at graphs are your reflections and your vertical and horizontal shifts. That's going to change the position. Like we just saw here. Your horizontal or your vertical shift moved it down. Your reflection flipped it upside down. A horizontal shift would move it left or right, like over there. Vertical shift moves it up or down. Reflection moves it, flips it upside down. That's going to change the position of your graph. Your stretch and compress, those are going to change the actual shape. So, like for a parabola, this would be your original. A stretch is going to make it thinner. Like stretching a rubber band, you make it thinner. A compress is going to make it wider. Like if you've ever seen those YouTube videos where they compress stuff and it smushes outward, that's what a compress is. It's smushing it outward. Your vertex is the point we're going to look at to find all the information from horizontal and vertical shifts. So when you're looking at a graph, we're going to go to our vertex. Your vertex is going to be that middle point of an absolute value, that point at the bottom. For a parabola, it would be that same point. For a square root, it's going to be that point where it starts, and it usually starts at 0, 0. Those are your vertexes. So our vertex here, the dotted line, that's the original parent function. We want to know the new function, the black line. So what did it do? Well, first of all, what is the vertex? Well, we can go x and y. So it goes over 1, up 4. So that's our vertex. 1, 4. X, then y. Okay, and then, so what are our shifts? Do we have, what are our transformations? Do we have a reflection? Did it flip upside down? Yes, it flipped upside down. So we're going to have a vertical reflection. Now y'all can abbreviate these when you type these into the computer. I put this at the top of your screen. For vertical reflection, we're going to use VR. For vertical shift or translation, we're going to use VS. For horizontal shift or translation, we're going to use HS. Instead of writing out the whole stretch by a factor of, you can just write stretched by and whatever the number is. And instead of writing out compressed by a factor of, you can put compressed by whatever the number is. So use a little shorthand so you don't have to type so much. So that's what I did here. Vertical reflection is VR. It flipped upside down. What about a shift? That's the word I'm going to go in. Vertical reflection, we got that. Do we have a vertical shift? Did it move up or down any? Yes, it moved up 4 spots. So it was a vertical shift up 4.
Second lunch, dine in, head to the cafeteria.
So that's your vertical shift. Did it have a horizontal shift? Did it move left or right? Yes, it moved over to the right 1. So it's a horizontal shift, right 1. For stretch or compress, you want to look at the slope of the very first point. So originally, the very first point is always going to go up 1, over 1. What is this one doing? Is it still 1 over 1? This one's going down because it reflected, but we don't have to worry about the down. Is it still 1 over 1 to get to the next point? Yes. If it had gone 2 over 1, that would be a stretch of 2, stretch of 2. If it had gone up 1, but we had to go over 2 to get to the next point, say it went out there, then it would be a compress of 1 over 2. But this one stayed at 1 over 1. So there's no stretch or compress. Stretch or compress. There's none of that. Okay, so what's our domain and range? How do we do domain? Domain, we're going to go left and right. Start on the left. What's on the left? An arrow. That means infinity. What's on the right? An arrow. That means infinity. Of course, the domain is going to be x. You have your less than inequalities. What does it mean if it goes from negative infinity to positive infinity? That's x equals all real numbers. X equals r. So what about range? What direction do we go for range? We go bottom to top. Start at the bottom. What's down there? At the bottom we have 2 arrows. So that's negative infinity. At the top, that point stops at 4. Range, of course, is y. Get your less than inequalities. And are we equal to? Is there an open circle at 4? No, it's completely closed up. It's solid, so that's equal to. Now, as always, we don't write our infinity, so we're going to take that out. Then we're just left with y is less than or equal to 4. Okay, let's try 2b. So what is our vertex on the square root symbol? That just means where is this one starting? Where's the bottom of it? Still at 0, 0. So do we have transformations? I'm just going to go down my list. Do we have a vertical reflection? Did it flip upside down? Nope, your arrow's still going up, so it did not flip. Was there a vertical shift? Did it move off of 0 and go up or down? No, it stayed at 0, so it didn't go up or down. Is there a horizontal shift? Did it go left or right from 0? No, again, it stayed at 0, so there's no horizontal. Is there a stretch or compress? For stretch, it's going to be greater than 1. For compress, your slope is going to be between 0 and 1. So what's our slope here? Find the next point. We have 0, 0. What's the next point? 1, 3. So find your slope. How much does it go up? Rise over run. It rises 3. What's your run? 1. So rise over run, 3 over 1 is 3. So is that a stretch or compress? Well, it's greater than 1, so that's going to be a stretch. So it's going to stretch by 3. And then because it's greater than 1, it's not a compress. So that's everything. Only one transformation. So let's find our domain and range. Domain, we're going to go left to right. So what's on the left? Well, it starts here at 0. What's on the right? An arrow, so infinity. X goes in the middle for domain, and your inequalities are going to be less than. Are we equal to 0? Do you see an open circle right here? No, if you don't see an open circle, it's going to be equal to. Now, as always, we can't use infinity, so take that out. And our x has to be first. Your variable has to be first. So we need to flip this around, which also means we flip our inequality. So instead of less than or equal, it's going to be x is greater than or equal to 0. Okay, let's try range. Range, you're going to go bottom to top. So what's at the bottom? It starts at 0. What's at the top? Infinity. Of course, range is going to be y, and you're going to put your less than symbols. Is 0 equal to? Do you see an open circle right there? Or is it solid? It's solid. There's no open part, so that's equal to. As always, we can't use infinity, so take that out. And our variable needs to go first, so we need to flip this around, which also means we flip our inequality. So instead of less than or equal, we're going to put y is greater than or equal to 0. So quick review. Watch your vertex. Did it move left or right to the new one? Did it move up or down? That's going to tell you your vertical and horizontal shifts. Did your graph flip upside down? Did your arrows change from going up to going down? That's going to tell you a vertical reflection. And last, did your slope change? Your original slope is always going to be 1. 1 over 1, which is 1. Did it change from 1? This one did not. It was still 1 over 1. But B did. It went up 3 over 1. So that one changed to 3. If your slope is greater than 1, it's a stretch. If your slope is between 0 and 1, it's a compress. So greater than 1 stretch, between 0 and 1 compress. Okay, so y'all try your practice with all your graphs and your equations. And good luck and welcome back again.